This is an overview of the last 12 months of testing and modifying from first test to controlled flight. The first time spinning the blades, I remember the excitement and trepidation not knowing what was going to happen. I had spent over £5,000 at this point, nearly 1,000 just on the blades, and 4 to 5 years building this. That combined with the potential danger of spinning blades up to 400 miles an hour, perhaps you can understand how I felt. I also perhaps added to the trepidation by telling everyone I knew about the project and also made a YouTube channel. I'm not a gambling man, but there was certainly an element of this in the beginning. However, I didn't decide just to leave it as a static display, which was tempting. I had enough confidence in my design calculations to proceed, so that's what I did. The first engine-powered blade spinning took place on the 1st of July 2021. Gradually bringing the blades up to higher and higher RPM each time was the procedure, visually checking for any cracks or bent bolts due to the increasing centrifugal forces. Once full RPM was achieved, I was happy. Knowing the blades and rotor hubs could take the full load was a significant relief. I couldn't believe how smooth the rotors ran. I was expecting it to take weeks of balancing to get to the full RPM, but full RPM was achieved on the same day, and what a great day it was. I had some engine issues at this point which took a while to sort out. It transpired the float chambers in the carburetors were in upside down. That fixed, I was able to gradually start applying pitch to the blades. With the gradually increasing load on shafts, belts and the clutch, this was also a nerve-wracking time, and probably more so than the first test. I knew full well what a broken shaft could do spinning at 5,000 RPM. Gradually increasing pitch, grass and hedges started to move around, indicating air movement. On the 22nd of July 2021, the first lifting was achieved. It was only lifting the front of the machine, but it was something. This turned out to be all I could achieve at 4 degrees blade pitch. Increasing pitch further didn't result in enough lift to pick up the whole machine, which I was bemused at. I decided to change the gearing from 5.6 to 1 to 7 to 1 to bring the rotary RPM down, increase the rotor torque and increase the engine RPM. The next test was in October and I was hopeful of getting the machine to finally lift itself, but this wasn't to be, to further bemusement. I did manage to test the rotor articulation in roll for the first time, and although it was harder to move than expected, there wasn't anything of concern. I knew the bottom rotor would need more pitch than the top rotor, but didn't know by how much, so started it off at half a degree. This was one of the reasons the amount of lift was lacking. The trouble is, until the whole machine lifts, you don't know if the torque on each rotor is balanced. Increasing the pitch differential allowed the machine to finally lift itself, which was a great relief, as I was starting to become despondent about the lack of progress. Now it can lift itself, I wanted it to lift me as well. An unlikely outcome at this point, I thought, but to my surprise it wasn't far off. A small push with my feet was starting to lift the machine. However, again, I've reached the limit of capability. I knew the cheap universal exhaust wasn't ideal, and it was really my last option to improve lift. I set about learning what I could about two-stroke exhaust design, and with the help of a great YouTube channel, designed twin expansion chambers. It took a long time to make these, but the results were well worth it. In February 2022, the first attempt lifting myself and the machine was a great success, with throttle to spare. Now I had a machine that was capable of flight, but no onboard cooling or yaw control. With the cooling and yaw vanes made by the end of April, it was finally time to properly test the machine. This time the tilting head would be completely unlocked and full directional control was possible. Again, the test went extremely well and the video got the attention of Supercar Blondie, who posted some information on her media platforms. The next series of testing over 3 months was sorting problems like a broken drive component, exhaust cracking, CG and control modifications, at the same time teaching myself to hover in a safe manner. I really didn't know what method of teaching would be the right one, but if I had to do it all again, there isn't much I would change. I would still start off with short tethers, but soon add 5-meter poles to the skids. Tethers are a safe way to test the machine at the early stages, but once you start teaching yourself the controls, more freedom is needed. I consider myself a patient person, but it was hard to prevent myself from going too far too quickly. I had some instances where I was really trying to run before I could walk. Those little moments where you think you have achieved a controlled hover and want to go higher are sometimes brought back down with a bump. This process cannot and must not be rushed. When I was learning RC, I smashed up a few blades because I wasn't patient enough. I think we can all understand that blades contacting the ground would be very different than the radio controlled version and would likely result in the complete abandonment of the project. There is still more I would like to achieve and more to come. For example, out of ground effect hover, slow forward speed and pedal turns, etc. But first I must get better at hovering. Hopefully I can keep the machine operating long enough to achieve these goals. The project has been massive for a person working in their spare time and has been quite a task. It's really all I've done for the last 5 years apart from the day job. So if you want a project that consumes masses of time, several £1000s and takes over your life for a few years, then I can highly recommend building one. But in the same sentence, I can say it's the most rewarding thing I've ever done.